Okay, so now we have a recording going, and now we can begin with the actual content of the meeting. So to start off with, we're going to make a spreadsheet. How joyous and exciting and fun does that sound? So we're going to start by saying, what are the requirements of our sensor design? What are the things that are important when we decide what sensor we're going to end up using on our final aircraft?
The size.
Size, correct. And what does the size influence?
Weight.
Everything.
Yes, but what specifically does the length and weight of the sensor impact?
Scoring.
Correct. Scoring. That is our first requirement. So
Ability to fit inside the airplane.
right. And how can we word that in words that don't sound so simple?
Oh, we're engineers here.
Yeah, we got to make things almost unintelligible to the average human, but it's the almost that's important here.
Integratability.
Integratability, got it. Perfect, absolutely. So what is another important thing about what our club specifically has to consider with making our sensor here?
3D printer requirements.
Correct. And what's a way of making that not sound so?
Oh.
Manufacturing requirements.
Yes, manufacturability. Because we're all about the
Like it.
abilities here. Okay. Are there any other things that we should say as our requirements?
Stability.
Stability, correct. Thank you. All right. So we have scoring, integrability, manufacturability, and stability. That's 4 things. Let's think of a 5th. What's important here?
Visibility. We have to be able to see the LEDs.
Visibility. That's right. Anything else?
Has to be able to be retracted into the plane.
That's more of an integration thing. Also, can someone, one of the leaders real quick, share the meeting link in the Slack chat, just for everyone else's sake?
All right, on it.
Gotcha. All right, so we have scoring, integratability, manufacturability, stability, visibility. Any more ilities? We gotta complete the combo there. Anything else? Anyone thinks anything at all that's important? Should we include style points in our decision matrix?
Aesthetic ability.
Aesthetic ability. That's pretty good. I'm pretty sure that's a word.
It's not.
So the next thing we have to do is rank these. So what is the most important thing? We will rank these 1 through 6. So which of these is the most important? Number 1.
Scoring.
Yeah, that's pretty important. What do you think is the second most important?
I think stability should be number 1.
Yeah, now I think of it, yeah, stability, because if it's spinning around, then we get
Okay.
score 0.
We can actually have them be on the same level too.
What? I don't know if that's fair.
Yeah, that's okay. It'll work out. Trust me. I hope. I think. I dream. So we have scoring. We have stability. Is there anything else that should be on this level? Sorry, I'm used to having my.
Nah.
Stuff over here. Let's just.
Well, technically visibility, right? Because without that, we don't get our score.
Right. So that's also pretty important. Manufacturability, that's like, we'll say that's a solid 3 out of like the scale of importance, because it makes my job easier, but there's only one actual sensor that we have to build, so it's okay if it's a little bit harder to actually make. Integration is solid 2. That's pretty important. And aesthetics, you know, we want our center to look cool, but it's ultimately not that important. So we'll put ranking, and then over C3. Ah, that's why.
Sorry.
So now we have a scale factor, which if I reduce the number of points here, so now we have a scale factor by which every one of the following mission designs will be then scaled. So let's just let me fill these in. So now we have different teams. Those of you who have so far submitted designs include Team Kevin, Team Evan, Team Derek, Team sticky keys. Gosh, uncultured. Next, Team Yoga. And has anyone else submitted designs?
I have.
Okay. Yeah. So, Team Jack. All right. So,
What about Ivan?
oh yeah, Team Ivan, of course.
The original.
The original, the OG. So now we have our 6 teams, and then we will. So, 8. Just drag this along. We'll rank each team a certain number of points. Probably 10 being the greatest amount of points and 1 being the least amount of points on the abilities of each one of these teams in that specific scenario. So let's do this. And let's give it a nice color. Let's a nice yellow. All right. So let's start off. Minor problem here is I don't actually know whose design is who. So if this is your design, please call out.
Yeah, that's kind of mine.
Okay. All right. So let's go over this. So if we pull up our grading spreadsheet here. Oh, not this one. This is
Oh God, what is that?
That's nice.
that's Excel. We don't use that here. We use only the most.
Close this off.
Yeah. I will actually keep that open because I don't know if you want to save that or not. Too bad. It's being saved. There we go. Okay. Yeah. Sorry, I'm grabbing the wrong thing here. The wrong edge of the window.
So y'all can see both screens, right?
No, they can only see one. I can try and put it on both. Yeah, let me try
Or-
that.
No, I meant like both windows get open.
Advanced. Yeah, I'll share screen 2 instead, just so it's bigger and easier for everything else.
David's been used to my setup.
Yeah. So we pull this over here. You guys can see this. Oh, gosh, you have to scale. Yeah, you have to like seriously zoom in. Wow.
Never used slower than the screen.
You got this. It's like that. All right, almost with that later. Okay. Sorry for the minor delay here. Let's bring up this guy. So, you guys do see the screen, right, with the SolidWorks window and the.
Yeah, we see both.
Yeah, it looks good.
Okay. So, yoga. So, I'll be honest, the scoring thing doesn't really matter in this competition because I didn't give you guys good, or I didn't give you guys a specific length or weight requirement or length or width requirement as long as it met the 4x1 ability. So we'll just scale that based off of the actual measurements of it. So if I come over here and measure from its widest point to its.
I just realized I didn't take into account the fins for the diameter to length ratio.
Okay, that's fine. So you have 5 inches wide and to the tippy top of this. Ah, it doesn't like that. Sorry, this is my bad. Scaling from that.
I think you're gonna have to deselect some things first.
Very true. Let's just mash escape a couple times. It usually fixes things up.
So it works, yeah.
Doesn't want to select the nose. Just put there. And put it back. So it's 6.51. So you have a 5 to 6, so that's a 1.25. Is that 5? Right? Sorry, this isn't your fault. This is mine. Tape a couple times. Okay, so it's 4.81. So it doesn't meet the scoring requirements, but that's okay. You know, it's something to keep in mind for the future. So let's put that as like a 2, because this thing will be pretty heavy, and that's actually good for us. So that's a good thing in that. Integratability. Because of its good length to width ratio, it would be fairly easy to integrate into the fuselage. But we can't really score the rest of it, kind of. So let's put that at like a 3. It'd be very easy to manufacture. Let's put that at like an 8. This shape, I imagine, would actually be really stable. It's got that big fins and big good length to width ratio, which actually would make it very stable. Let's put that at like a 7. Doesn't really have visibility concerns in there, but because of its dimensions, it would be fairly easy to actually integrate that finally. Let's put that as a 5. And while it is a good first attempt, I'll be honest, it does look kind of ugly. I'm sorry, I gotta be honest. So we'll put that as like a 1.
You also don't have the scores weighted.
Yeah, I don't have the scores weighted. Okay, so how would I do that?
Go to the 26.
Yeah, I know.
Equal
Equals-
cell times cell.
that would be. Fixed. It doesn't. All right, that's fine. That's easy enough fix to make. We will just insert one left. Insert one left. So we'll just have this be equal to uh, we'll just drag this over a bunch. Let's do start with a minor delay here. I'm not sure F3. No. Oh, actually should have worked. So insert. K3. Mouse button doesn't work. Insert one right. So this should be K3 times that. That's what I did. All right. So what's that equal to? Darn. That should be that. All right, we'll fix that as we come to it, but that should be all that is equal to the sum of O to O. All right. A total of 18 points. Let's just get rid of that. All right, congratulations. You got 18 points. So, yeah, I know. You guys can still see this, right?
Yes.
Yeah.
All right, so 18 points. Not bad for the first attempt. Okay. Now let's bring up this one. So whose design is this one?
That one's mine.
All right. Kevin's design. All right, so Kevin. Okay, so as part of a scaling factor, we will first check to see what his diameter is. So it's 1.5, but the fins seem to be farther out. So we'll check on that. So about 1.78 across. Right? No, they're 2 across. Got it. It's off center. And then we'll measure from here to here. SOLIDWORKS and its always intuitive measuring tools. So 6 by 2. So that's an aspect ratio of 3. So that is slightly more than what is required. So we'll put that as like a 7. So now integratability. The shape should be pretty easy to pull into the actual aircraft itself. It's got a spot right here for a, what I assume to be a tow line to the aircraft.
Yeah.
Okay. So he has integratability in mind. And the general shape, there's no weird protrusions or anything. So that makes it pretty easy to integrate. So we'll put that as like a 8. Manufacturability. This would honestly be kind of hard to 3D print because it has this rim, this small surface area on the base to actually print from either side. And this cone would also be kind of hard to 3D print. But it's doable. Probably put that about like a 5 or a 6. Stability. It's got the fins for the roll stability, and it's got the frustrum for vertical stability. So I'll put that as like a 8 or 9. Let's put it at 8.5. Visibility. Again, it'd be pretty easy to integrate different lights into this. So we'll put that as like a 8. And aesthetics. It reminds me of a missile. The nose is pretty pointy. Be a good hypersonic vehicle, or actually a not good hypersonic. You want leading edge radius, but well, you know, it's got that classic missile shape. Let's put that as like, what do you guys think? What would you rate as the aesthetics of this?
7.
7? I got one call for 7. Any other calls for any other numbers?
7 sounds good.
7? All right.
7.
7 it is. 3 calls for 7. So total right now is 43.5 points. All right. Now let's see what Evan's design looks like. So this thing is pretty wild. Evan, you want to walk us through your design right here?
I mean, I can. It's
Alright.
really not done. I didn't finish it in time, so there's no hook point or anything. But I took a thick cambered airfoil. Had to be fixed with the battery inside. But it's an airfoil camber that's designed for human-powered flight, so they're for very low-speed flight, much as like our aircraft is going to be performing. It's got a single stabilizer in the back for yaw stability. The goal is to create some sort of lift so it can counteract some of its own weight. Obviously, it's not going to create enough because of the low aspect ratio. It's going to lose a lot of those edge effects and not create a whole lot of lift, but it'll be at least a little bit. So hopefully the increase in lift against weight will counteract the drag that the actual shape makes. Right now, I haven't put any roll stability on there. I was going to put some sideways spins on it to help with the roll. So right now, I didn't have to test it to see what it would actually do.
So that
It
to
looks like a piece of salmon too. If you guys are into salmon, yes,
It needs some winglets.
What was that? Evan that said that? I guess we can't fire a chief or
Yeah.
test pilot, but
yeah.
you're fired for that.
We can promote him to safety officer.
Ooh, that's true. Run him out of my hair.
The ever-encompassing Daredevil's punishment.
Yep, absolutely. Let's see if I can actually get the measurements out of this. Okay, so it says it's 1.5 long. Now, if I can actually get it to tell me how wide it's.
It's 1.5.
Yeah. So how long is it, Evan?
6.
6?
Should be exactly 4-ish.
All right. Let's see. Between this
Yeah, should be
and
6.5.
yeah, I could ever. Yeah. My gosh. All right. Let's just pull out this thing. You have it.
Yeah, I believe I saw it was 6 long and 1.5 wide.
Okay. So it meets the scoring requirement. How do you think the volume efficiency of this is actually? Like how effectively does it use the weight? Like how, like compared to a regular shaped object, how heavy do you think this is? How much volume does it have to put more weight in?
Just for me.
Yeah.
My own design.
On a scale of 1 to 10,
How much will it use its weight?
how well it uses its volume to create weight?
Yeah, there's a lot of unused space inside there, but you can also do it empty.
Okay.
I don't know. I'm gonna put it up to the group. It's a little bit. It's probably not. It's definitely not like the top tier. There's a lot of wasted space inside there. So I don't know, maybe a 5 or 6 on that one.
All right. 5 or 6 it
I lift
is.
my own rating up.
7.
So if someone else says like 3 or 4, it could be,
Yeah. Just drag this down. All right. So interchangeability or integratability, not the best. I think this will have issues when it is actually like coming into the fuselage of the aircraft.
the top fin could break off pretty easily.
Yeah.
So could the rear. The rest of it stay together.
Okay. So let's put that as like
It's got a very narrow, like very
That's
square area, but pieces will break off. Don't do it
so
right.
I'll put that as like a 6. Because it might start around some issues when it's being towed back into the aircraft. Manufacturing. It'd be pretty easy to print this out, depending on how you printed it, either like flat against this. You might put some supports on here, but oh, I guess actually I'll actually mark this down a little bit on integratability prior to what it was. Because the other thing about integratability is how we're going to fit in the electronics. And it's going to be pretty hard to fit in the electronics.
I put a lot. I fixed very thick airflow, so there's a lot of
True.
room inside there. I don't know how big batteries are.
Mhm.
I didn't get any specs on that. And then how big are those batteries?
They're fine.
Depends on what batteries you get.
We did have a,
You could-
spec for a certain battery size in one of
You
the,
could find them in like any size. So
You have a 1.5 by 1 battery.
I don't know how big that would be off the top of my head.
it probably exists. We'll bump that up to 5.9.
Thanks, brother.
Manufacturability, it's fairly manufacturable, as long as you pick a flat side to print it on. It would change probably with how he fits in the fins into the sides. So for now, let's put this as like it's about as manufactured, a little bit more manufacturable than Kevin's form factor. Put that as a 7. All right, stability. What's the pitch stability like?
Pitch stability.
Mm.
So at high or low rumbles and there's got a decent pitch stability. Positive. Well, so it wants to nose down,
Okay, that's helpful.
which is what we want because it'll be towed from front.
Mm-hmm. Have you thought about where you're going to put your toe point in relation to the
About quarter cord.
quarter?
Yeah, a
Alright.
little bit in front.
Okay. As it currently stands, the roll stability isn't the greatest. Again, that's
So it's about 0.
yeah. It's something you haven't considered yet.
Winglets.
Winglets, of course. Yeah, something like a lifting body. Like the like Dream Chaser. You guys have seen that space reentry vehicle. It's pretty cool looking. Might be good. So because it doesn't have, it has good pitch stability. It has good yaw stability because of that fin in the back, but it doesn't have good roll stability. So it has 2 of the 3. So let's put it at 2/3. Actually, in relation to what we put the other one at, 8.5, it's probably like a 7. Give you the extra 1/3 of a point there. Visibility, you could probably
You put
fit in some LEDs on the underside here. Because no one cares about underside flow. It's the top side flow that matters.
You want to slow down the underside slope.
Yeah, exactly.
They get stagnant here and
Mhm.
it's higher pressure. Just you and Aaron, and what I'm talking
Absolutely. All right. Aesthetic ability. I don't know.
about. It looks like a piece of sand.
What's
Ah,
a
3.
A 3? I got a 3 in the. I got a 3 in the peanut gallery. Anyone else have any scores they want to put this at?
Give it 4.
What for?
4.
Hey, thank you.
3.9.
Okay, we got 1 9.
Wow. Someone really likes their sand.
Let's go with a mode instead,
Oh.
or median instead of mean.
All right. Let's do. So we have 1 3, right? A couple 4s. How many 4s do we have?
Actually,
We have a couple 4s. 4 4s. We have 1 9.
That's really gonna help my case. Thank you.
Yeah.
I'll second the 9.
That was a 3.9.
So we have 2 9s, 4 4s, and 1 3. Is there any other cases before we close?
I'll do a 1 just to bring it back down.
Okay, a
I'll
1.
put a 3 to bring it back down.
We'll replace one of the 4s with a 1.
I'm keeping my 4.
Okay, you got one person keeping the 4. Okay.
Danny, you're running down.
It's not me leading you down, it's democracy.
I said Danny. Danny.
Oh, okay. Sometimes you say Dan.
I love democracy.
Yeah. This is 8? What? No. I don't want this. What? Okay.
You're doing better than this.
I don't know. Fine. What?
Some divided by.
should have done this in Excel.
Listen. All right.
You had it so.
Divided by blank. How much is that? 1, 2, 3, 4, 5, 6, 7, 8. It's wrong. 4.25 is your average.
It's better than the 3 that Jack gave me right off the bat.
Okay, okay. Oh, you're behind Kevin's score. Now let's see. Derek, did Derek send me his? He did. My man.
Y'all ever seen Little Boy?
What?
Little Boy?
Oh, Batman,
Fat Boy and Little
Batman and Little Boy. All right. So here is Derek's thebomb.com. Derek,
Score
you wanna-
11.
I can, but my mic ain't working. I don't know why.
Okay, Derek, explain yourself in here.
Explain myself.
Explain yourself.
It's a relatively simple design. It's just
Okay.
a football shape with a tail cone on it, essentially.
Football with tail cone.
Basically.
Yeah. All right.
The cool part is it really what it looks like. It screws together.
Screws together. You put
Yeah.
threads on this?
Yeah, so if you cut it down the milk.
Oh, would you look at that? There's some threads right there. Wow. There's one part, you say?
Yeah, it's technically a one part file. There is a 4 for it, but for some reason it didn't
He really considered everything.
put
Yeah.
thickness in yet.
Maybe I'll just have friction fits. Yeah.
So
How
I
well am I
have
going to be able
the-
to 3D print this? Let's guess.
it can be split into multiple parts. It doesn't have
I
to
know,
be
but like
explicit.
3D printing threads is something I haven't gotten to do that yet.
3D printing threads is easy.
Say you.
I have printed them on multiple occasions.
Say you.
Fair enough. I don't know. I also have to put a mounting lug on it because I would want to kind of move the mounting lug around as if
Okay.
if this shape ever decides it wants to fly. I don't know if it does. I'd want to move the mounting lug around to see if I can balance it. Well, at some point we'll throw it up though.
Yeah, something.
I mean, yeah, but I would want to like move the mounting lug, to see if I could balance it statically. Very important. But statically and flight.
Okay.
Well, because too far forward, it's going to be tail heavy. Too far aft, it's going to be nose heavy. So see if you can balance
So
it.
here's the problem.
But it'd be on the top load. What? Oh, it's 3 to 1, isn't it?
3 to 1.
Oops. Let me make it an inch longer. I'm solved. 2 inches longer. That was big. Give me a minute. This was late at night.
Okay. Okay. So it doesn't meet the length to width ratio. So
Ugh.
what do we say that score is if it doesn't meet the ratio?
You're going to put me at 0.
I got one call for 0. Anyone else have any calls?
Oh, come on. Somebody give me a
Pity 5.
Pity
Yes.
5? Okay.
6.
5.
5.
5.
What is the score for?
ability to score.
Well, should be 0. But
Oh,
Most of the others have
you can
units, so it's
change
like-
that.
no comment.
No comment? All right. I heard some 5s. I don't want to do the average thing again. That took too much time. Let's put it as a 5. Okay. And let's see what the interchangeability or integratability is. It's a round shape. It'd be pretty easy to just drag into the fuselage. It's probably like one of the easier ones because it's very self-contained. There's nothing to like snag on. So I'll put that as like a 9. It's probably the most integratable. Yeah. Manufacturability. Besides my own inhibitions about the spirals right here, it's a pretty easy print to do because it's just you print like this basically, and these things act as support for the circularness of everything else, and you print this piece. So that's pretty manufacturable. That's fairly easy for me to print without any issues. So I'm willing to call that as like a 7 or an 8, probably like 7.5, 7.45 actually. About 7.45. Stability. So
I have no idea.
yeah.
It might be okay or it might be garbage. It looks
So-
like a little face. I think it really depends on where the mountain is,
Yeah.
which is why I wanted it to be kind of up in the air.
We roll stability should be fairly good because it has these things. Pitch stability. I don't know.
Well, pitch stability is going to depend a lot on if you can like statically balance it.
Yeah, I'm gonna say
Especially with this design.
yaw and roll are pretty good. Pitch is a little sus. If this was Among Us, I'd probably vote pitch stability off. But I'm gonna call that a 7. 7 for stability. Actually, I'm gonna call that 7.5 because I think it would be more stable than Evan's design.
Well, there's a lot of things more stable, especially in Google.
Yeah.
Pitch.
So visibility, again, you just have things coming out. So I'm willing to call that an 8, like we have most of the others. What if it was visibility? Actually, I'm gonna bump yoga score up to an 8 because there hasn't been anything explicitly bad about anyone's integration of stuff. Aesthetics, I like that it kind of looks like a bullet or like a fat or a mini nuke. If any of you played Fallout.
Yeah.
11 out of 10.
I give it 9.
Okay, so the average is at 10 right now.
I give it 0.
A 0. So the average is at like I don't know. It's too late for math. Any other
Isn't that
opinions
6
on
point?
20.
6.2?
Actually, I like that it has a face. I thought that was
Okay, bumping up to a 5. All right. What would you say the average is there? About 7. Oh, come on. Ah, of course. The backspace key is broken. It's the delete key. That's why it's broken. Exactly. It's delete. Yeah, and so it's broken. Really?
Should give it a 0, but
Ah, why is that? Ah,
What is it about pop and stuff?
yeah.
it was
Come on. That makes sense. Because you got less on the scoring than Evans. Yeah, that's what did you in. Yeah. All right. Yella and Max. Let's see what you guys have for us. So you guys had this one.
Yeah.
All right. Let's start with the all-important making sure to fix my mistakes in the Excel document. Okay. Ah, that was the wrong thing to fix. This should be, delete these actually. It's L3 times D3. All right. So let's start with the, of course, the measurement of length to widthiness. Okay, so it's 6 inches long, and this has a radius of 0.68, which means its actual radius is like 1 1/3, right?
Yeah, the fins poke out to 1.5 inches in total diameter.
Okay, and that is a 4-to-1 ratio, if I'm right?
Yeah.
Okay. All right, I'm willing to accept that explanation. Okay, so we took that into consideration. It looks like it's a pretty good use of the available volume. It could technically be more efficient if it was more squared, but I mean, actually, no, it wouldn't be. A circle is the best. Yeah, circle is best. Okay. Yeah, for volume it would be, because otherwise you can have a situation where you have like a diagonal length that's more.
Okay.
So yeah, a circle is best. It also depends on how they actually score these things, which is unclear. So it looks pretty good. That's not till later. So it scores well on the scoreability. I'd probably put that as like a, let's do 8. 8. Let's call 8. Okay. Now let's see what is the integratability. They have multiple toe points, and what's this on the inside here?
These are ports for screws to connect the multiple pieces.
Okay. So they have that taken into consideration, how the two pieces fit together. That's pretty good. I'm going to give that as like a 8. Integratability into the thing. Actually, I'm going to call it points off slightly, because there is a very small chance that this could get snagged. So 1.8. I'm in the right screen. It's a small but appreciable chance. And also, technically, these mounting lugs would be outside of the radius, I'm pretty sure. Unless you have these even. Are they even?
I can't remember.
Okay. Looks like they're slightly above the profile of this, so 7. Easy fix, but still a knockoff in the current design. Manufacturability. This is multiple pieces, right?
Yeah, it is.
Okay, so it is slightly diagonal. That's probably the way I did this. Okay, so you have like a locking lug there to prevent rotation, and you have 2 screws that come in to keep it attached. Actually, I think that is a channel for the thing. Okay, so the multiple parts are pretty easy to 3D print, especially when you have this is one piece, which I like. That's one of the advantages of 3D printing, is make everything one piece. So I'm going to call that an 8, not 7.8 this time. Stability. You got the fins for roll and yaw stability, and the frustrum for pitch stability, just general stability. I'm willing to call that as pretty stable. Let's call it an 8.5.
Stable 8.
Very stable. Stable like my mental
No.
health. Visibility. You can put in some LEDs here. That wouldn't be that much of an issue. As we can do with everyone else. Let's get it. overall, I mean, it's pretty standard. There's no wow factor here, to be honest.
It's like something I can't imagine in school.
True. True.
ASU sponsored you, and I cannot tell you what that is.
Okay. What is everyone else's opinion on what would you give the aesthetic score on this?
I'd give it a 10.
Okay, you got one vote for 10,
I'd give it a 10.
8.
8, 7,
7.
7. Anyone else? All right, let's. All right, well, let's give it a 7.8. 7. There we go. 7.6. That's what I meant. Okay, so Jack, do I have your design? Do you have a design?
I have it open up on my computer. I emailed it to you, but
Let me-
I can just share screen if you want me to.
Yeah, let me see if I can. I have to join on my phone again in order to get you in. Oh. Hey, Nitish, can you send me your sensor design in an email to my ASU email? I don't have access to Slack on this computer for it.
Yeah, gotcha.
Got it.
Also, you're host, so you should just be able to change it.
Oh, I am host now. Thank goodness. I thought I had it. There's a lot of things open on the screen. Participants. Jack, make him co-host. No, make him co-host. I still want host. All right, you should be able to open up your.
All right, here we go. My amazing pitch. Okay.
Make sure you share your screen.
All right. So, like the great designs before it, these French tumble home battleships, I've adopted a tumble home design as well. And here it is. It's a
Beauty.
Oh wow, that's bold and brash.
all right. So
Aesthetic score of 0.
no, it's 10. Anyways, so it is 6 by 1.5, so it's a 4 aspect ratio exactly. It's broken up into let me get the explode view. So I don't know how you're supposed to do this. Okay, I'm just gonna hide it instead.
Okay.
All right, so it's broken up into 3 parts: a tail section, this joint section right here, and it's already dimensions. So if you want 3D print it, it should work. And this front section, it's pretty great. I think it's obviously 10 on aesthetics. It has some light holes. It's got the stability down. If you check that CG, it is noticeably below.
Very
But-
noticeable.
Yes,
It'd be better if you had like some depleted uranium weights in there.
yes. As you see, the tumble home design, it pushes the center of mass towards the bottom. And as you can tell from the renowned French Navy, it worked really well on their pre-dreadnought ships.
Yes.
They certainly didn't have any problems with stability.
Wait, what's old is new again though, and that the
Yeah, I know.
Zumawalt has the tumble home, but okay.
Yes.
So I will say, it looks like you made a pretty efficient use of the weight for the volume available. And it does meet the aspect ratio thing. So I'm willing to give your score a 9. Let's say a 9 for an 8. Okay. So next is integratability. You clearly thought of that. You already have the towing points attached in there. The one thing I will say is that the third piece, that's more of a manufacturability thing, but you have plenty of room inside for electronics, plenty of areas to have LEDs come out. So I'll say that's annoying as well. Manufacturability. The one thing I would say to make it easier would to have the like the joint and the tail be one piece instead. It's a fairly easy change to make, but it's just easier to print that as one piece.
See, one thing I wasn't sure about is I could place this tail in this T configuration, or I could place it in X configuration. I don't know which is better for stability, or if it really does anything. So.
Some inspiration to look for there is submarines. Submarines often have cruciform, which is just up and down, or up and horizontal, and then an X form tail is another thing that they do. So you could look for some inspiration there in why they do the things the way they do. So yeah, that's something to look at. So manufacturability, slight markdown for that. I'm willing to put you at like an 8. All right. Stability, looks fairly stable.
I honestly have no idea how this tumble home design would work, because you have this face, like normally in the water, the upper part of the ship doesn't really contribute to the stability, besides just where the center of the mass is. But this, it's pretty much acting as another fin, but I don't know if that would help or hinder.
So we have to drag this through the water to make sure it's stable?
I don't know.
Yeah, does someone have like some sort of small tub that we can use?
I got a pool.
Yeah, that would work. So I think it looks pretty stable. There's nothing especially unstable about it. There might be some weird pitch stability, unsteady flowness things going on, but that's beyond my purview. So I'll call it an 8. Integration, I'm going to put that as an 8 as well, because we haven't given anyone else an 8. Looks, here's the most I don't know how to put this. The most debated
3.
of the night. A 3? You have a 3.
Yeah, I'm gonna put it at 2, as you can see in the comments.
Aesthetics.
Even the person who made it put it a 2?
Yeah, it's pretty ugly. Just look at the front. I couldn't even properly loft it.
So we have a 20, we have a 3, we have a 2. Anyone else have any strong opinions on this score? Anyone in the chat?
I'll put it as a 5 for effort.
5 for effort. All right, we can have the 20 in here, so we'll add a 2 and a 0 is separate.
All right, I'm giving the screen share back to you.
Okay. What is the sum of 3, 2, 2, and 5?
And 0.
Yes. Make sure to remember the 0.
Don't forget your screen share.
Yeah, I remember. I remember the 5th of November. So that's 7, 12 plus 0, so 12 out of 5. 2.4 is your aesthetic score. Not bad.
I'm almost number 1, if you're counting the other way.
No, this is actually winning because it's wow. That's insightful.
By the way, share your screen.
Yeah. You guys haven't seen the final score yet, so. All right. So you hear you got 32.7666667. So that's pretty good. Ivan, you're here, right?
Yeah.
All right.
I'm working on the second prototype, but I haven't had a lot of time to do it.
That's fine. I don't actually have yours up on this computer, or do I? Do I have it? Do I have your assembly on here? That is
Daniel, what happened to your computer?
What happened to my computer?
Yeah.
I don't want to talk about that. Everything is fine. Fine. That's not it. Okay, I didn't email myself the assembly, so I'm just gonna go off memory. I know you had the 4:1 length to width ratio. It was the most efficient use of volume though, so let's call it an 8.5. Integratability, it had some, I liked how it had the ability to do multiple configurations for the shape, but it was a little, the tail I think was a little bit too long, which would have made it have some issues with when we're tracking it, I think, maybe. So I'm only gonna put that as like a 8. Manufacturability, I printed it about 3 times now.
Yeah, I think it's very good.
One of them failed because of my fault. The other one, I accidentally snapped off one of the bits. And the third one, I had to glue the bit back on. My suggestion to you is to make the tail one piece.
Yeah, that's what I'm doing.
Yeah.
I could just finish that, but I still have to do some other stuff.
Okay, that's fine. So with those improvements in mind, the fact that one bit keeps snapping off shouldn't be that big of an issue. So I'm gonna call it a 7.2. So and there's stability. It's got the what was the word I used for it earlier? Flange bit frustrating. It's got the frustrating. There's not that much compared to stability that you did differently than the other teams. It's just basically vanilla and maxes. So they got a 7.5, I think, 8.5 for stability. So you're gonna get an 8.5. Visibility. I'm just gonna put that as an 8 for everyone. And aesthetics. Does everyone remember what this looks like?
I can probably share my screen on my phone and take a picture, but
It's like an 8.
Okay, if you want to share your screen real quick.
Right.
I wonder if, does that work on your phone? Sure. You can try. I will get the last thing set up first for Nitish's sensor design.
All right. You said sharing?
Let me stop my sharing and see. It doesn't look like it. Try again.
Should be. Just put a picture in the comments.
Yeah, I should put a picture, or put it in the Slack. People should be able to see it in Slack.
Oh, that's true.
All right, I can't actually see the Slack, so go ahead and let me know what you guys think once you see it in the Slack.
It's assembled in the picture I have on my phone, but you can kind of see how it's gonna be.
Yeah, I
and
would
the
say an 8.
bottom is supposed to be like heavy for the stability.
Oh. What's the difference between the two? Oh, one's an STL. Got it. All right, so let me know what you guys think about the aesthetics. What would you score that out of 10?
8. I
8?
like it.
Okay. Anyone else?
I'm at 8 as well.
All right. Yeah, I'm willing to give it an 8. All right. Tish, last but not least, here's your design up on screen that you guys can't see. So let me share that once again. All right. You guys should be able to see this wonderful design right here. Remember, you guys are on camera.
You made a screw.
Yeah.
Yes. Bar square.
It is 8 by 5 diameter. Interesting. Which,
I
yes.
believe, didn't you make this before we really looked at the rules?
Yeah, yeah.
Okay.
None of the proportions are correct per se.
Okay. This looks like a fairly easy shape to make longer, though, but because the current iteration doesn't have the right dimensions, we're going to put that as like a 5. And because technically this wouldn't make a very good use of the volume in terms of creating extra weight, that's what I'm also going to do. And the other thing that was brought up is that it has a lot of surface area for what it is, because it has
Right.
this internal channel, which increases our drag. So yeah, a 5 is a good place to put it. So integratability, this looks like it'd be fairly easy to drag back into the plane. I'm going to give that an 8. Manufacturability, I could probably just print this straight up. It wouldn't be too bad. We'll give that as an 8. Stability, I don't know
That's a-
exactly how you can get roll stability out of this.
So I mean, yeah, I should have added that, but like it's on the assumption that the tow rope is on the top section. So the top is defined by the pointy edge. So
Yeah.
where all the mass is. So putting all the mass in closest to the center of rotation.
Mm-hmm. Wouldn't you want the mass to be as far below the center of rotation as possible, then? I guess it depends on how you carry it. So stability, it's a big depends. Not the typer. I'll put it as a 6 for now. Visibility, it would be kind of hard to integrate lights. You could probably put it on the ring, but like fitting a battery and then the sensor or the electronics in here to have them stick out, you could gain more by having an enclosed volume in the middle to put stuff in. So I'm gonna put like a 4 on that, probably. Yeah, I'll put 5. All right. What's the aesthetic score on this, do you guys think?
4.
Yo,
5.
that's too high.
4, 5,
I'm gonna vote that a 1.
a 1, a 6.
3.
It's original.
Yeah, it is very original. I'll put that as like a 3. 3.6439.
Does the battery go in the top part?
Yeah, yeah.
Section. Okay. All right. So what matters now is this. So we have Kevin at 43.5. We have Evan at 39.15. Derek at 29.233. Daniela and Max is 47.7. Yoga is 21.41666667. Jack as 32.77. Ivan as 33.4 and Nitish as 23.58. Yeah. We'll probably print off like, I don't know, top 3, top 4. Check them off the building sometime. That's a lot of things to print. That's my time.
Well,
The most valuable time of all.
however you were willing to print Daniel
Yeah.
as El Presidente.
I have a printer too.
Okay. Yeah, I can send you a couple of these to print. I'll probably print, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8. We'll probably we'll print the top 4. Yeah, so that'll be Kevin's Daniela, Evan, Jax, and Ivans. I'm sorry, Jack. Yours doesn't make the cut.
Oh no, and mine's toleranced and everything.
I can print yours. For the people who got in the top half but did not do well on their scoring because they are out of spec in terms of the length to width ratio, please fix that and send the updated STLs to me. And also keep in mind that I'm gonna have to print these, and so you should add some tolerancing on the parts that are supposed to be friction fit together. They should not be a no tolerance fit. There should be some sort of fudge factor there to account for the horizontal expansion of things. So, yeah. All right. That's all I have planned for this meeting. We went pretty long, so I'm going to call it there. Thank you all for showing up on this slightly unusual day. And yeah, is there any other questions?
Unrelated, I got the closet stuff. At 2, I'm going on campus at 2 to pick it up.
Okay.
So,
All right. Max, you're fairly close to campus, right?
Yes.
You want to go with him so you can check to see if the motor boxes are in there?
Yes, I would love to.
Okay.
okay, I will
CD,
send.
you said?
Yeah, I'll send you an email with their stuff.
Okay, cool. Thank you.
All right. And then for the rest of you guys, we are hard at work trying to figure out what kind of shape this airplane is going to take. We're doing the hard math, the hard science, the hard number crunching, lots of numbers, lots of crunching, very crunchy numbers, to try and figure out what size plane will get us the best score. So for the leaders, I will talk more about that at the meeting tomorrow. But other than that, that's about all I have to talk for. What are you doing? Sizing the aircraft. All right. Thank you all for coming, and I will see you next time.